Namaste. We have a simply supported beam of span length 10 meter. It is subjected to a concentrated load of 10 kilonewton at the center of the span. The modulus of elasticity of the beam is 25,000 Newton per mm square. The beam has a rectangular section of width 300 mm and depth 600 mm. The beam is assumed to be massless and having a single degree of freedom defined as the vertical deflection u under the load. Take the value of g as 10 meter per second square. The equation of motion governing the free vibration of the system is option A, u double dot plus 540 u is equal to 0. Option B, 10 u double dot plus 540 u is equal to 0. Option C, u double dot plus 6480 u is equal to 0. Or option D, 10 u double dot plus 6480 u is equal to 0. Now we will solve the question. It is given to us that the beam is massless and it has a single degree of freedom, which is the vertical deflection u under the load. Equation of motion for a single degree of freedom system is mu double dot plus cu dot plus ku is equal to pt. Since nothing is given to us about damping, C, the damping coefficient, is 0. It is given to us that the beam has free vibration, so no force is acting on the system and thus the dynamic force Pt will be equal to 0. We have our equation now as mu double dot plus ku is equal to 0. Here u double dot is the acceleration, u is the displacement, m is the mass of the system and k is the stiffness of the vibrating system. Now we have to calculate the value of the mass and the stiffness and put these two values in our equation of motion. We will calculate the mass. Since the beam is assumed to be massless, the only load acting on the beam is the 10 kilonewton load which is acting at the center. 10 kilonewton will be 10 into 10 raised to power 3 Newton. The value of acceleration due to gravity g is given as 10 meter per second square. So the mass will be W by g, which is 10 into 10 raised to power 3 divided by 10, which gives us 1000 kg. Now we have to find out the stiffness, which is load per unit deflection. We know from our knowledge of mechanics of solids that for a simply supported beam of length L and subjected to a concentrated load at the center of the span, the deflection under the load will be WL cube divided by 48 EI. If we do not remember this formula, then we have to go to strength of materials, the chapter of slope and deflection of beams, and derive this formula from there using any of the standard methods like Macaulay method, double integration method, area moment method, etc. Here the value of K will be W by delta, that is 48 EI by L cube. E is the modulus of elasticity of the system, which is given as 25,000 Newton per mm square in the question. I is the moment of inertia of the beam, which will be BD cube by 12, that is 300 into 600 cube divided by 12, since it is a rectangular section. The value will come out as 5.4 into 10 raised to power 9 millimeter to the power 4. The length is given to us as 10 meter in the question, that is 10,000 millimeter. We will put all the values and calculate the value of K as 48 into 25,000 into 5.4 into 10 raised to power 9 divided by the cube of 10,000, which gives to us 6480 Newton per mm, which will be 6480 into 10 raised to power 3 Newton per meter. We will put the value of mass m and stiffness K in the equation of motion. We get 1000 u double dot plus 6480 into 10 raised to power 3 u is equal to 0. We divide the equation by 1000, we get u double dot plus 6480 u is equal to 0, which gives us our answer option C. Thank you.